mentalspod.com, advancing life science research, connecting people and ideas.
Nola Masterson is here. She's the managing director of Science Futures, a 30-year-old investment and advisory firm in the life science space. Nola has been a leader in our industry. She was co-founder of Sequenom and wrote the first business plans for IDEC and Insight Vision. She was the first biotech analyst on Wall Street. She co-founded the publication Bioventure View, which was the first online newsletter about biotech. In 1987, Venture magazine called her the guru of biotech. For more than a decade, Competitive Group has helped science-based companies build and execute innovative marketing campaigns. They love science, they love marketing, they love the idea of combining the two to make great things happen for your marketing communications. Welcome.
Thank you very much. I'm so happy to be here.
So quite a few firsts here.
Yeah, I saw an opportunity at that time in my career, and I went, the window's open. If I go through it, I can look back in my career and say, I was the first, and I went, I'm going to do that.
Let's go back to that time.
Yeah.
So you got a law degree at Stanford.
No.
No.
I had a master's degree in biological sciences from George Washington University. I had been trained as a medical technologist, and I loved science. And I had been working for Millipore Corporation for almost 8.5 years, voyeuring science, talking to them about how to separate proteins, how to put DNA and into a mass spec, and because we had bought water, so we had chromatography, we had restriction enzymes. So I actually knew the science that was coming around and why it was important. And what I didn't see was anybody going to the financial community and talking to them about it. And I really thought the venture capitalists were having a lot of fun, almost as much fun as the scientists. And I liked them, and I wanted to help them. My long suit at Millipore was motivating people to get sales in the door. But as a middle manager in sales, they criticized me because they said, you mother your people too much. And I went, well, if mothering is my worst thing that I do, I'm going to make that the thing I really do. So I looked at biotech and I went, there's no mothers here. There's a lot of fathers. I'm going to mother this industry. I'm going to take it into my own and say, what does this child need at this stage in its career? And in 1982, it really needed somebody to go to Wall Street. And it really needed somebody sitting in the venture capital office of Kleiner Perkins and translating the science for the engineers that were working there, because they weren't trained in the science. And there were a lot of science projects that were coming to them to be funded, but that didn't necessarily mean they make big companies.
So two things there. You went to Wall Street,
yep.
But then you also went to Kleiner Perkins,
yes,
and served as this kind of go-between. I mean, now it's common for partners or managing directors.
Well, I wasn't employed by any of them. I started Science Futures, which was the management and consulting company that it still is today. And I had clients, and my clients were Wall Street. My clients were the venture capitalists. My clients were the companies that were doing biotech at that time.
What gave you the thought, I need to go to Wall Street and talk to them?
I wanted personally to learn how money made money. I personally had seen my stock at Millipore go up and down, and I didn't understand why. And I think this is true of most scientists. They think that the stock market is a mystery, and I wanted to learn it. But I was pigeonholed at Millipore in sales and marketing, and they weren't going to let me into the finance area. So the only way to learn finance was to service the financial industry in a way that gave me access to the information they had without having to go back to school.
What was your first business plan then? I mean, you stopped Millipore, I guess, and set up Science Futures.
Set up Science Futures.
And what was your first business model for Science Futures?
How to be a consultant. I took a 3.5-day course on how to write a consulting plan for somebody, how to program your time, how to write in your own profit, how to get other people to work with you and develop teams for different projects. So I took consulting as a serious role, and I wasn't going to look for a job while I was consulting. I was going to make consulting my business.
Okay, and what's an example of your clients back then?
Zoma Corporation, California Biotech, Amoco, which is now ExxonMobil, I think, oil companies, other Wall Street, people that wanted to have me weigh in on a Series C round or follow-on financing once companies went public. There were a lot of different financing tools in the early days that aren't existing now.
It was some creative financing.
Very creative. Yeah, it was really fun.
We attended with you recently this night devoted to talking about Chiron and Cetus.
That was fun.
And one of the things that came out was they had to come up with some clever financing models in those early days of biotech.
They did. And the financing models were as different as anybody had ever seen. And they were just like the science. Nobody had ever seen this kind of science before.
Why did the funding models have to be unusual?
Well, because there were no products that they were funding. They were funding research. And people
It's
were
like- it's
used
like-
to funding widgets and things you could count so that you had something to audit what was in your inventory. But we were now funding science. So that's why I call it science futures. Because it was a model that hadn't been seen before. It was actually funding a futures market to allow science to evolve. And it wasn't a futures market like pork bellies, where you could count the number of pigs that came through, or gold, or anything on the commodities market. It was number of PhDs under a roof. Where was their science headed? How many competitors were in there? How many people were working on alpha interferon at the same time? I mean, these were the metrics that you had to use to analyze for a financial model, you know, whether it was a good investment or not.
And it ended up being a great investment.
Well,
On
it
Wall
was-
Street, some of those early companies.
Some of them were good.
Even though they had no products, even at the point of IPO, right?
Right, it was hype and hope. And I used to call it, and it still is, but not as much, the naked R&D arms of the pharmaceutical industry. Because what it became was the pharmaceutical industry of today. But the pharmaceutical industry in 1980s and 1990s had products. They had Clairol hair color, they had Chiclet gum, they had products that they were selling into over-the-counter pharmaceuticals like Excedrin and aspirin. Then they had their far-out products, which they were trying to find the next blockbuster for cardiovascular, the next blockbuster for ulcers. And that was their research, but they didn't have to talk about their research because they had actual products. So who was doing the naked research without any products? The biotech companies were. So they were they were pharma of the future.
Okay, so connect us. You've set up Science Futures. You're consulting. Now that's in '82,
Right.
and eventually we're going to get to your co-founding Sequenom.
Sequenom was 93. It was,
90. Okay,
it was
so
a 10 years.
10 years.
10 years. I spent 10 years doing what I could do. Every year saying to myself, what does the industry need that if I do it this year, somebody else will follow me and the job will get done. So in the early 80s, there were no consultants inside pharma. There were no consultants inside venture capital firms. Now they're there all the time, and they can't work without them. They hire them, and now you have analysts out the wazoo at every bank has an analyst. But in those days, the biotech companies were such small cap companies that none of the pharmaceutical analysts wanted to risk their career to follow Genentech because it was such a small cap company, and the beta was so high. So the Greeks weren't in their favor, but I was able to convince a couple of them that this was going to be part and parcel of the pharmaceutical industry, so they should start to follow it. And that took 5 years. By 1987, it was a well-entrenched field. There were other analysts like myself. There was Stelios Papalopoulos, who inherited my portfolio at Drexel Burnham Lambert. I had moved on to Merrill Lynch, and we had hired a full-time analyst so I could work with other people. And I was still a freelancer. I was still consulting. And one of the main reasons I wanted to be free was because I had a small child and I was a single mother. And time was really important to me, and I didn't want to become owned by any one company. So that was the 80s. The 90s were a different era for me. Personally, my child was growing up. I hadn't figured out how to get her into college. I had remarried, and I had the security of somebody else being the father, bringing home the bacon. So I went, I can go for the big one now. I can start my own company. And that's when I started Sequenom.
Well, walk us through that.
I met the scientific genius behind Sequenom, Hubert Koster. He had been at Millipore after I left in 1985. They had bought his German company, Biosyntac, because it had blocking patents to the methylcyanomethyl chemistry that Applied Biosystems was using for its DNA synthesizer. and they had bought
These are the days of the synthesizer.
they had bought Biosearch in Mill Valley, and they didn't know what to do with the instruments, and they knew Hubert had a good background, so they put him in charge of a division in Bedford, Massachusetts called Millie Gen, and in 4 years he created 7 instruments, and developed a team of people that was 100 people, with 4 different CEOs heading up Millipore.
So you and he got together.
So we got together with a lawyer who introduced me to him, and he wanted to take a physics principle, mass spectrometry, and apply it to DNA to get the mass weight of DNA. And in '93, nobody was doing that.
Mm-hmm.
It was a
standard quality check now.
It's a standard quality check now, but it was absolutely only used for proteins, large proteins. It wasn't used for DNA. The thinking of that in that time was DNA would fragment in a mass spectrometer, because it's kind of like spaghetti.
Mm.
It would be like, but Hubert had an idea for chemistry to support the DNA, and he also had the idea of SNP analysis, of taking small segments of DNA and flying those in a mass spectrometer that had a time of flight path, and that if he got small enough segments, A, T, G, C could be analyzed based on their mass weight.
Each one has a different.
Each one has a mass weight, and nobody had thought to do that. So it was pretty gutsy at the time, because nobody was funding basic biotech at that time. It was 1993, 94. Those were not great years for venture capital coming into biotech. They had seen the bloom fall from the rose. We had had the 87 crash on Wall Street, and we had had a 91 high, and we were now in a trough. So I took a Tom Perkins model, and I asked TVM, which was a newly minted venture firm out of Germany, to back us and give us just $200,000, so I could finish.
What do you mean by a Tom Perkins model?
Tom Perkins gave Bob Swanson $200,000 to start Genentech.
Okay.
I knew this.
Okay.
I had history with Kleiner. I knew what Genentech, and I
Which is not much.
Not much. It wasn't even very much then. But it was enough for me to leverage that I had venture capital money. And then I could go to a leasing arm and say, we have this first investment by a venture capitalist. Will you give me $1 million lease line? And I'll give you, not only the money back, but you can get warrants for stock, which was the trade that you did in those days. And they gave me $500,000 in cash, and $500,000 once I got the next round of venture financing. And so I was able to buy Hubert a mass spectrometer to put in his lab in Hamburg, so we could start to get the if out of the science. Because it wasn't known that you could fly DNA in a mass spectrometer. But I said, if we can get that to work, then we will have a company.
So it was going to be a tools company.
It's going to be a tools company.
Applied Biosystems was probably going at the same time.
It started as a tools company, but actually the original business plan, which Hubert wrote, was about 40 pages long, and once he had the tool, he was going to evolve into proteomics, because he knew proteins were really where the drugs were.
As a service. Protein synthesis.
As a whatever, but we needed to get to this part first.
Okay.
Okay, so it was a long-term.
That's quite different from what it is today.
Yes.
And they're in the news a lot this last year with their.
Well, they had an unfortunate thing happen after they went public, and their public offering was in 2000.
Okay, so IPOs in 2000.
Yeah, they had a.
And you've called that the last big IPO.
Well, it was, because the stock priced at 26 on February 1st, 2000, and opened at 79. Those were Genentech proportions. And it ran to 191 in 3 months. So there was nothing bigger than that. But it also came crashing down when Blair and Clinton made a public announcement that they didn't think you could really do any patenting around genomics. And it was also the same time of the dot-com bust, boom bust. So genomics and the dot-com mirrored each other in that they were spectacular rise and then a spectacular fall. And Sequenom was unfortunately caught in that spike. So we used to call the public offering the Matterhorn because it had two sides to it. And Hubert there was a palace coup 4 months after the IPO, and I wasn't on the board anymore, unfortunately, and he was ousted and Tony Hsu took over as CEO, which in hindsight lost the vision of becoming a bigger company servicing pharmaceuticals and doing pharmaceutical drug development with the tool. The tool wasn't the end game, but Tony made it the end game, which kind of took it down a path of then as an analyst you see how many instruments you're selling, and Hubert was always known for making state-of-the-art instruments that were high-priced. So Illumina came along and cheaper, faster, better ways of getting mass analysis or DNA analysis came by. And so Sequenom had to play a catch-up game, and it was because they lost their leadership, unfortunately.
But you weren't there through that.
I just know.
You pulled out and you went on with Science Futures. You says, okay, been there, done that.
I went on and was asked, I was going to start my own venture fund with all my gains from my founder stock at Sequenom. So I created Tahoe Venture Partners. I was out marketing that deal when TVM came back to me and they said, we hate to lose you. You've been such a you've been such a help to us in the last 9 years, and we trust you, which was important in the German model. Would you mind joining us, raising our 5th fund with us, and opening the San Francisco office? And I said, that's a good deal. I will do that because German money was very. It had been the conversion of the euro into the dollar, was happening at that time. The Deutsche Mark to the euro.
To the euro.
So German money was really very well heeled, and even though we were still at a premium for real estate in San Francisco because it was 2000, we opened an office in downtown San Francisco, and I became a venture capitalist with a Boston office and a Munich office. And I stayed with TVM for the next 6 years.
Let's talk about your thoughts today.
Okay.
About the industry in general, and I mean, what excites you when you get up in the morning about this industry?
Well, the industry's evolving, as science always will. So what's exciting is the single cell analysis tools that are out there. The ability for scientists to look at finally understanding that each cell has its own personality.
Right. It's almost like we were overlooking this big opportunity.
But I kind of lost the religion of DNA when I read Bruce Lipton's book, The Biology of Belief, which explained to me in simple terms, and I always like to take science and put it into simple terms for people because my father was an orthopedic surgeon and he would talk in really esoteric terms at the dinner table, and it annoyed me. I promised I would never do that to scientists. I would make things simple. So Bruce's premise was you can take DNA out of a cell and pluck the nucleus out of the cell. The cell will still live. You take the membrane away from a cell, the cell immediately dies. Everything happens at the membrane level. All communication in the body happens at the membrane level of every single cell. And now that I finally understand that, and I watch them doing single cell analysis, it's absolutely true. We have 50 trillion cells in our body. They're all talking to each other all the time. But it made a link for me, which was very philosophical. That's the mind-body connection, because they're listening in on your thoughts. And they're communicating at the membrane level, whether you're stressed, whether you're happy, whether you're, exercising, and, it all fits together finally at the vibrational level.
There's a whole community going on.
There's a community.
Speaking one to another.
Exactly.
And so that's what you mean by you've given up on the religion of DNA.
Yes.
Like you were,
dogma.
before you were too focused on the central dogma.
The central dogma. DNA and RNA.
Well, it is the central dogma.
It used to be. And you know what they say about dogma, don't get too involved. Yeah.
So
that's what I'm excited about today. I'm excited about the fact that because we understand that things happen at the membrane level and that the single cell is important, we're starting to go down a path that I think will allow us to go into an area of medicine that nobody would have thought of even 5 years ago. Which is taking the vibration of molecules that work, such as Taxol or cisplatin, and a low frequency radio wave, introducing that at the site of cancer and having it cure cancer without any demolishing of the cells surrounding that cancer. And there's actually a little company in Seattle that I'm working with as a consultant that's doing quite just that.
So you're just absolutely thrilled and inspired by the science that keeps going
It will keep
forward.
Going. It will always keep going.
We have some favorite topics here at Mendel's Pod, and one of them right now is bioethics.
Mm-hmm.
You know, like Sequenom, for instance, is doing the prenatal diagnostics now.
Mm-hmm.
And there's this the issue coming up over, is the test so early, right, that it makes abortion easier, right? And so there's the ethical conundrum there. There's the GMO ethics, right? Europe doesn't want to do the GMO thing. We're okay with it. And I'm just wondering if you have any thoughts on this, because you've seen over the years.
I do.
I
absolutely have thoughts on bioethics.
And I have this hypothesis that we have to have a lot more discussion there
for the
industry to advance.
Oh, we do. We do. And ethically, in the early days of doing recombinant DNA work, if it hadn't been for Paul Berg and the Asilomar conference, we wouldn't have been able to do some of the early experiments. We wouldn't have been able to create a Genentech. We would. And if you look at in vitro fertilization, there was a huge bioethics around. Can we take a cell out of a woman? Can we take the sperm from a man? Can we make a test tube baby and then put that back in a woman? Is that ethical? And
now it's standard.
Now it's standard of course, because what you have to understand is, Larry King did a really fascinating interview with the Dalai Lama in the 1990s, because he was asking this question: should we really explore the DNA? Should we really look at it in depth? I mean, are we really messing around with God? And the Dalai Lama said, of course we should, because the closer we get to it, the more we'll be looking at the face of man, who is the face of God. And so
scientists are actually the ones who do see the face of God.
They do, and the more scientists that I know, the more I realize that they have religion, they have awe, they have wonder, they have respect for life, because they see it at its earliest beginnings. They see it at the core. And I very rarely met a scientist that wasn't also, had some artistic bent. And you heard that from Bryn. Was he a writer or a painter or a musician? Because there's so many dimensions to life. But the ethics of science is, what do you do with the information? Not, do you continue to do science? What do you do with the atomic bomb? What do you do with the ability to split an atom? What do you do with the ability to get down at the vibrational level and start to cure cancer? Do you keep that away from people because the drug industry wants you to? If you can find a solution, how can you help mankind? I mean, you really have to get humanitarian here. And the more science understands how the body heals itself, and the body is an amazing healing machine. The body wants to heal. The body goes in the direction of healing. Disease is not a norm. Pregnancy is not a disease. These things have been made into a disease model, and really what we need to do is get back to what's optimal health.
The wellness model,
right,
away from just reacting to disease.
Exactly.
Yeah. Another thing we love talking about here is open science. This has been a pretty strong movement in the past couple of years.
Mm-hmm.
And I'm always curious what someone who's worked in venture capital thinks of this. Because the idea is to share data, and pharma is starting to do collaboration with universities more.
Oh, yeah.
And there's a push to open up clinical trial data, right? So in the name of science and advancing science faster, let's open up. But on the other hand, things are closed because of intellectual property and protection.
Well, I'm the chairman of the board of Repros Therapeutics, which is in phase 3 clinical trials for a drug, a small molecule that works on the pituitary hypothalamus axis to help men with low testosterone and metabolic syndrome. Our clinical trial portfolio is open to any partner that would like to see it. And that's an open model.
Is that unusual? Is that a first?
No, I don't think it's the first. I think it's the way that a small biotech company has to be in order to let pharma in. And pharma won't come in unless they see the data. It's all data driven. Science always has been data driven. So is it right to open the data? Yes, if you have a confidentiality agreement and some laws around what you're going to do with knowing what that data is. It's imperative, actually.
It's imperative to open up, but you just have to get creative in your ways of protecting yourself with the NDAs and.
Right, exactly.
Yeah.
And I remember when I first saw the World Wide Web, I thought, this is great. Because scientists can talk to people from all over the world. They can put their data up on here. You know, it's what the kind of thing that you're doing at Mendelspod. Gets it out faster than waiting for a journal article that's been peer reviewed. That's the way of the world today.
Mm-hmm.
Because no idea is in a vacuum. If the butterfly wings in Japan fall off, do we feel it over here? The answer is yes. Everything influences everything else. You can even make your cursor on your mouse move with thought now. So, can you keep a thought down? I don't think so. And we've got all the IT behind it that's supporting it. And I'm bullish about the IT and the computer industry coming in to biotech and bringing it into the 21st century.
Yeah, I mean we've run stories on this.
Yeah,
you know,
that's
as IT taking over bio,
and it is.
They're sort of cannibalizing every industry. And biology lends itself because it's really an information science.
It is. But biologists have been trained in a different modality than engineers, so they need each other, and they need to talk to each other. So we kind of need the Genentech model of the IT biologist all under one roof, where they have lunch and they have pizza and beer on Friday, and they think, how can I, make what you're doing and what I understand about how the body's working, improve the life of man? Those are the questions that should be asked now.
What are your thoughts today? We hear a lot about new funding models, and you focused your career on funding, really.
I have, and the venture capital model is never going to go away completely, but it is winding down because of the time that it takes to get a pharmaceutical product to market. So
it's winding down.
It is winding down. There are very fewer and fewer firms that are specialized in this area.
Is that a trough?
There will always be some, but what's coming in to fill it is the pharmaceutical companies all have their own venture fund. The crowdfunding is coming to fill in the gap for the first and second rounds, and there's super angels out there. So you're going to have investors always. I used to call the early venture capitalists the backers of the old days were kings and queens, and that would supply the money for the merchants to go and find the United States or go on
exploring. Journeys.
We'll always have some people with money that will basically fund the explorers. Scientists are explorers. So, will the model change? Yes, it's evolved. It will evolve.
So you're an accomplished horse rider, and that's one thing you weren't the first to do.
No, I definitely was not the first. It's a childhood dream come true for me. I grew up in Virginia riding horses, but there were 6 in our family and 8 years, and my mother wasn't about to put a horse on top of that, so I only got to ride the stable horses. And when Sequenom went public, I bought my own horse. And so that's been the start of reclaiming the childhood I wanted that I didn't get.
We all do that.
Yeah.
And so you're still riding?
I'm still riding. I'm doing lots of trail riding, lots of camping, and I'm doing Los Altos Hounds, which is basically going out and doing the traditional English hunting, fox hunting.
Well, thank you for coming on the program.
Thank you.
Nola Masterson is the Managing Director of Science Futures. For more than a decade, Competitive Group has helped science-based companies build and execute innovative marketing campaigns. They love science, they love marketing, they love the idea of combining the two to make great things happen for your marketing communications.